Yes, welcome again to my mathematics online tutorial, and in today's class I want to teach us integration by substitution. Integration by what? Substitution. We have three good examples on the board for us to solve, and they are very simple. So let's consider the first one. Solution. The first one is integrate, number one, integrate ln x all over x dx. Ln x all over what? X dx. Ln x is just like logarithm. Now, we say by substitution. So let u be equal to ln x. We are substituting u to be what? Ln x. It therefore means anywhere we see ln x, we put what? U. Now, we are going to be differentiating u with respect to what? X. That is, we differentiate this function u with respect to x. So now, we have du dx, du dx. So what is du dx? When you differentiate ln x, you have what? 1 all over x. Please, don't be confused. We have u equal to ln x. We are differentiating u with respect to x, we have 1 over x. Now, our target is to get the x. What is the x? So let's cross multiply. From here now, cross multiply, that is x times du, then dx times 1. So dx times 1 is equal to x times du. We have what? S du. So it therefore means anywhere we see the x here, we are going to be putting what? S du. Look at it. Dx is equals to x du. So we want to eliminate, we want to remove this dx. So we will now substitute. So of writing dx, we put s du. So now, question 1, this function becomes integral. Look at it now. But the s is what? We say the s is u. Alright? All over x. What is ds? ds is what? S du. Please, when you check very well, we have substituted ln s to be u, and also the s to be s du. Instead of writing ln s now, I wrote what? U, because we said u should be ln x. Look at the u. The s is still there. Then the x, we said it should be what? S du. Now, we can cancel s, can cancel this x. So we are now left with integral u du, which is a very simple function that we can integrate using the power rule. Now, how do we integrate this? U, the power rule. No, check very well. U is to power 1. So we now say 1 using the power rule. What is power rule? Look at it. U n plus 1 all over what? N plus 1. Because we are dealing with the function of what? U. So now the power here is what? 1. So therefore means U, the power is 1, which is n. 1 plus 1 all over what? 1 plus 1, because n is also 1. So u, we now have u, 1 plus 1 is what? 2. 1 plus 1 is 2 plus what? C. What is c? C is what we call the constant of integration. That is, the result of this integral problem is u squared all over 2 plus c. So this is the solution. We are done with question number 1. So let us proceed again to example 2. So example 2 is also very simple. Look at it. Number 2, say integrate sine 2x minus 3. This is just like function of function. 2x minus 3. So we can just assume and say let u. Remember, we are using the method of what? Substitution. Let u be equal to 2x minus 3. So the first thing to do is to differentiate the u with respect to what? X. Now, du dx is equal to what? Du dx equal to 2. Because when you differentiate 2x, you have ordinary 2. Differentiating minus 3, you have 0, because minus 3 is constant. So du dx is equal to what? 2. Now, what is our target? We want to remove this dx. So from here, my dx, let's cross multiply. cross multiply, du is equal to 2 ds. See, this is just like over 1. So du equal to 2 ds. But our target is to get ds. What is ds now? We divide both sides by 2. Dividing both sides by 2, now we have du all over 2 to be equal to ds. Now we will substitute ds to be du over 2 in this original function. And then also, so from here now, this function is going to be reduced to, we have sine. Mind you, 2s minus 3, we said it should be u. So we will not write 2s minus 3 again. We just bring u. Alright? Now we have ds. What is ds? Du over 2. Du all over 2. Now, this 2 is denominator. Alright? So we can still rewrite this to be 1 over 2 to be serving as a constant sine u du. Alright? So look at it, 1 over 2 is taken to the back because it's serving as a constant. We have sine u du. Now, this function has been reduced to just sine u du with 1 over 2 as a constant, which is taken to the back. Now, remember what is it called? When you differentiate sine, you have cos. But integration is opposite of differentiation. So when we differentiate sine, we will have cos. Now, integrating sine, we will have negative. Well, take it again. When you differentiate sine u, you will have positive cos u. So since integration is the opposite of differentiation, when we integrate sine, we will have negative cos u. So therefore means we have 1 all over 2 minus what? Cos u. Then plus c. What is the c? C is constant of what? Integration. C is constant of integration. Now, we can go back. Then, permit me to do this. Now, we now have 1 over 2 minus cos what? U plus c. This can be written as minus 1 over 2 cos u plus c. But mind you, we said u should be what? Equal to 2s minus 3. We said u should be equal to 2s minus 3. So at the end, we now have minus 1 over 2. Instead of writing u now, we just say cos. What is my u? 2s minus 3 plus c. Even in the first example again, we are supposed to go back and substitute the u to be equal to what? Ln x. Anywhere you see u, you just put ln x. So also in this one, since we say u should be equal to 2s minus 3, we will now substitute u to be what? 2s minus 3 plus c. And this is what? Done. Very, very simple. So now, we can consider the last example. Now, number 3, integrate sine x cos s ds. So we can say since it's we are using substitution method, we can say let u be equal to what? Sine x. Let u be equal to sine x. So that from here we will find du dx. What is du dx? When you differentiate sines and x, you have cos s. Cos x. And now let's cross multiply. So du equal to cos x dx. If you look at this critically, there's a relationship between this and this. Alright, look at it. There's a relationship between this guy and this one. So it means we can reduce this function to be like this. Sine x, alright, cos s ds. Let's just write, instead of writing cos s ds now, we make it to be what? Du. And also check very well. We said u should be sine x. And now we have sine power 3, sine 3x. That is, so what are we going to do? If u is sine x, so here now we can rewrite this to be integral u power 3 du. Look at it again, because sine x is equal to u. And we have sine cube x. So instead of writing sine 3x, we just say u cube du. So now we will integrate this using the normal power rule, alright, which is equivalent to what? U 3 plus 1 all over what? 3 plus 1. Mind you, plus c. What is c? C is constant of integration. So from here, we can have what? U over 4 all over 4 plus c. Please, let us not forget this. We will go back and substitute u. What is our u? We said u should be sin s. So let's go back and substitute it and we are done. So u, we said u should be sin x. So anywhere we see u in that solution, we put what? Sin x. So look at what we got. U power 4 all over 4 plus c. What is u? U we say sin x. So here now we just say sin sin x all over 4 plus c. And this is the result. Look at it again. We say u power 4 all over 4 plus what? C. Plus c. What is u? We say u should be equal to sin x. So instead of writing u power 4 now, the u now, you can bring it to be sin 4x over 4 plus c. Bye. God bless.